about how we are using union and structure to map a state machine. So previously what we saw is how to use or how to map a peripheral register using as example of GPIO register. In this example we'll be saying consider we have a state machine or a communication register. So in this example I'm taking an RX, so an input from the user. So this program will get an input from the user, so that's called RX. I have named it as a com register, which is a communication register. This communication register has different parameters. So it's RX state. Since we are going to do only RX, I am having an RX state machine here, and the RX state machine has a done bit, in progress, and idle. And then another member called RX state you can either access through bits or using these bit fields, or directly use the RX state. This is called a communication register. So let us see how we are going to use this communication register to navigate to different states using these bits. So here I have shown a simple main program. So in our communication register, let us say we are initializing our communication register. So communication register has a value of RX states. This puts all the value to its initial of 0. Next, so now here I have written a simple program which continuously waits for some of the for any of the user input. Here we have 3 options as a user input. So user can query what is a communication state, user can start a transfer and end a transfer. So this program is going to only receive the transfer. The user is responsible for transmission or ending the transfer, and he can also query the communication state. I'll say example, if options OPT options equal to 1, so what get com state to return the com state. When to printf, so what is the communication state, /n/r for a new line only, com state is a com state, percentage x 0x dot rx state. Or else for you can for readability, let us have like state sorry, what are the states that we have: done, in progress, and idle. Done, percentage d, comma, in progress state, in progress state, percentage d, and what is the other state? Really idle, percentage d. So bits dot done, comma, com reg dot bits dot in progress bids dot in progress. No, idle state, sorry, idle. Yes. We are just trying to simulate a transfer, or just trying assume, but in a real RxTX scenario you are going to send it as a byte. So just for your understanding, I had just added a printf, and I have emulated RxTX using a scanf and printf. If else if options next is it's equal to 2, what would be the next option is to start the transfer. So when he's trying to start the transfer, let us assume like transfer uh, we are going to do a 1 byte transfer. So scanf, again get a scanf, enter data byte percentage d data underscore t data. So we're going to enter data. And you're going to, so let us say if the data is greater than 100, you're going to blink a GPIO. So in our previous example we have seen reg ports dot port pins dot this GPIO is going to become high. Or you say you toggle a GPIO every time you get a value, every time a data byte is entered. What will you do? Yes, so it's 1 and next time it is 0. Simple example. Next option, let's say else if, what's going to be the next option? 3 n transfer. PTI options equal to 3, sorry 3, you're going to end the transfer. So what will you do in end transfer? Once you have received all the data bytes, so you will be processing the data bytes. So let us make it still more some communication process. So scanf, enter data byte. Once you have entered the data byte, you can do end transfer. Once the transfer is ended, what do you say? And once you start transfer, initially all the values are 0. It means a COM state is an idle state, right? Idle reg dot bids dot in progress. Yeah, you have started the transfer, so this is in progress. Next, if a transfer is already in progress if you're going to reject the transfer. In progress means printf it's already sorry, rx lorry already in progress. Now once you want to end a transfer, and transfer equal to 1, you make n transfer equal to 1. So idle, only in an idle state you can start a new transfer. So when you start a new transfer, you make com as in idle state. So let us initialize our com state to idle. Com state is idle now. When you get, so option 1, when you get the com state, you will print all the communication state. Option 2, want to start a transfer. This program will just only receive a single data byte. Once it has received the data byte, next it expects end transfer. Option 3, once you end the transfer, you go into idle state. Communication in progress. So only in an idle state you can start a new transfer. Let us say you can design it. It's a simple example. You can add more bits, say error bits, like that. Let us say if options equal to options equal to 2 and register in progress. If a transfer already in progress, aborted, or x ABO or bot or x already in progress, abort ABO, reject transfer. J is reject new NSFERS transfers, rejects new transfer. So let us say if you are going to start a new transfer, and if a transfer is already in progress, you will be rejecting a transfer. Else if options is 1, you are going to get the com state. Option is 2, you are going to in progress when you want to clear the in progress. So you have to clear the in progress state. In progress 0, transfer has ended. Now let us say if idle, yeah, I think this should be fine. Okay, let us try to execute this program. Window. So let us get the com state now. What what's happening here. Okay, let's correct our program. Printf scanf, percentage d conversions. Let us try if this works.